So there's a massive showdown happening in the tech world right now. You've got two giants, Apple and Nvidia, and they are both fighting to be the brains behind the artificial intelligence that runs on your personal computer. But here's the thing, they are coming at this from completely opposite directions. And that brings up the big question that, let's be honest, a lot of us are asking. If you really want to get serious about AI and run it locally on your own machine, what do you buy? Which way do you go? And let me tell you, it is not as simple as just looking at a spec sheet. Because this is so much more than just a hardware debate. This is a clash of philosophies, really. It's a fundamental disagreement about the best way to build a computer for the AI era. You got raw power on one side and slick efficiency on the other. Specialization versus integration. Okay, let's get into it. To really get what's going on here, we first have to understand the two totally different game plans these companies are working from. Okay, so on one side, you've got Nvidia. Their whole thing is just maximum power. They build these ridiculously powerful specialized graphics cards, GPUs, that you slot into your computer. And look, they're the undisputed champions of raw speed for a reason. They're the industry standard. But then you have Apple, and they're playing a completely different game. Maximum integration. Everything, the CPU, the GPU, the AI accelerator, it's all fused together onto one single chip, a system on a chip. And they all share this one central resource. And believe me, that's the secret sauce here. And that secret sauce, it's called unified memory. Think about it like this. Imagine you're in a workshop. The Nvidia way is like having a separate room for your saws, another for your drills, and a third for painting. Every time you finish a step, you have to pack up your project and carry it down the hall. It's slow. Apple's unified memory, though, is like having one giant shared workbench where every tool can access the project instantly. There's no wasted time moving data around, which for AI is a huge bottleneck. And that leads us straight into round one of this fight, Apple's secret weapon, the massive advantage in memory and efficiency that this whole integrated approach gives them. Get this. 512 gigabytes. That's how much of this super fast unified memory you can pack into a top-of-the-line Mac Studio. And you have to understand, when it comes to AI, memory is king. It's everything. The bigger and more complex the AI model you want to run, the more memory it's going to gobble up. And 512 gigs is just a mind-boggling amount for a desktop machine. And hey, this isn't just some abstract number that looks good on paper. The Verge really nails it here. This massive pool of memory is an absolute game changer for anyone who wants to run the most advanced, most sophisticated large language models right on their own machine without needing to connect to the cloud. But it's not just about how much memory you have. Apple's system is also just shockingly power efficient. And the hero of that story is a specialized bit of silicon called the Apple Neural Engine, or ANE for short. The best way to think about it is like a custom-built calculator that's designed to do one thing and one thing only, the very specific kind of math that AI thrives on. And it does it while using as little power as humanly possible. And this chart, wow, it just lays the difference bare. This is from some academic research, and it shows the power used for a core AI task. The main GPU on the M4 Pro chip, it needed 24 watts. But the specialized Apple Neural Engine, doing a comparable job, just 5.2 watts. That means it's getting the job done using less than a quarter of the power. I mean, that is just a staggering efficiency gain. So what does all that efficiency actually get you in the real world? Well, take a tool like WhisperKit. It does speech-to-text transcription. Because the ANE is so good at its job, this tool can run entirely on a Mac and achieve world-class accuracy. In some cases, it even beats the big cloud-based services, all while just sipping power. That's the magic right there. Okay, but this story definitely has two sides. While Apple is just crushing it on memory access and efficiency, there's another metric where the tables turn completely. Let's talk about raw, unadulterated speed. This quote from a user on Reddit just cuts right to the heart of it. For certain tasks, the Mac just feels slow. They talk about prompt processing. That's the initial thinking time an AI takes before it starts spitting out a response. And training or fine-tuning, well, that's the process of actually teaching an AI model. And that is just incredibly computationally intensive. And this is exactly where NVIDIA's whole maximum power philosophy pays off big time. When you need to crunch an immense amount of data to train a model from the ground up, or when you need the absolute fastest response time possible, the raw horsepower of a dedicated NVIDIA GPU is simply in another league. It's what the entire professional AI industry is built on, after all. So let's put it all together on a scorecard. If you're just running big models, what the pros call inference, Apple is excellent because of that huge unified memory. Nvidia is often faster, yeah, but you can be limited by how much memory is physically on the card. Now, for training models, it's not even a contest. Nvidia is the industry standard. Trying to do it on a Mac would be painfully slow. And finally, power consumption and noise, Apple wins, hands down. It's super quiet and low power. A high-end Nvidia setup, on the other hand, is going to need a lot of power and cooling, which usually means a lot of heat and fan noise.
This other Reddit comment just perfectly captures Apple's unique value proposition here. It's not about being the fastest. It's about accessibility. The Mac is the machine that lets you say, wow, I can actually run this massive, state-of-the-art model right on my desk. Doing that in the NVIDIA world would require an incredibly expensive, multi-GPU setup that most of us just can't get.
So where does that leave us? Which machine is right for you? Well, it really all comes down to what you're actually trying to do. It's all about your specific workflow. Let's break it down. Make it really simple. You should choose Apple Silicon if your main goal is to run these huge, already trained AI models locally. If you care about having a quiet, power-efficient system that just works right out of the box, the Mac is your champion. On the flip side, you choose Nvidia if you need the absolute maximum speed for training and fine-tuning models. If you're building a dedicated workstation where performance is the only thing that matters, and you're not too worried about the power bill or the fan noise, then Nvidia is the clear one. And that all leaves us with one final big question about the future. As AI continues its march from these huge anonymous data centers into the devices we use every single day, which philosophy is ultimately going to win out? Is it going to be Apple's big bet on the incredible efficiency of an integrated on-device system? Or will the relentless demand for more and more raw power mean that the specialized high-wattage approach will always reign supreme? Only time will tell.